Okay, 10.3 notes, polar coordinates, page 6, the final page. So example 11, it's going to look like what we just did on example 10. We want to rewrite this polar equation. We've got r equals the square root of r cosine theta plus 2. We want to rewrite that as a Cartesian equation and then write in the standard form of a conic if possible. So quick reminder, let's go down here. Our conic sections. We've got a circle, which looked like x minus h squared plus y minus k squared equals r squared, where hk is the center and r is the radius. Holy moly, radius. We had an ellipse, which looks like x minus h squared over a squared plus y minus k squared over b squared equals 1. HK is still the center. And A and B gave us distance from the center to vertices either along the x-axis or the y. We have the equation of a parabola. Actually, two equations. We had y minus k squared equals 4p times x minus h. And we also had x minus h squared equals 4p times y minus k. hk is our vertex. And then depending on whether y is squared or x is squared, we know that this either opens up, down, or left, right. And we also had a hyperbola. Which looks like the equation for an ellipse with a minus in the middle instead of a plus. Again, we have our center at HK. A lot of texts will write this two different ways. They'll put x minus h squared over a squared or x minus h squared over b squared, depending on which is the larger number. As long as you're flexible in realizing that the a goes with the x or the horizontal component, the b goes with the y or the vertical, you are fine. So these are the general forms that we are trying to put these in as we rewrite this. Okay, so let's take a look at what we got. I got r equals square root of r cosine theta plus 2. My r cosine theta is an x, but I really don't want to write r as the square root of x squared plus y squared. So I'm going to start by squaring both sides. And then I get r squared equals r cosine theta plus 2. R squared is x squared plus y squared. R cosine theta is x. And so I'm going to move all of my variables to the left-hand side and give myself a little space here. Now I've got to rewrite this. I've got a positive x squared, a positive y squared. This looks like it's going to be a circle. And so I need to complete the square so that I can write this in the standard form of a circle. So to complete the square, I'm going to cut my coefficient in front of the x in half. I've got -1. Divide that in half, I get -1/2. I'm going to square that and add it to both sides. This turns into x minus 1/2 quantity squared. We made it that way. Plus y squared equals, I want to change this to an improper fraction. 2 is going to be 8 over 4. That makes this 9 over 4, which is 3 over 2 squared. So it looks the way I want it to. So this is a circle. I know that if I need to identify it, my center is at 1/2, 0. My radius is at 3/2. My radius is 3/2. I know that a lot of you that took college algebra in the spring may have got this shortchanged as we move to online. So if you need a reminder about any of this, please don't hesitate to let me know. All right. So, moving on, example 12. We've got 6 different equations. We want to change from polar to rectangular. The reason for putting these in here is just so you see different ways to look at this and you know how to think about this as you move forward. So r equals 4. I don't really want to replace that with square root of x squared plus y squared. So again, I'm going to square both sides. I get r squared equals 16, which I can rewrite as x squared plus y squared equals 16. Up here it says for consistency, always set the final equation equal to 0. X squared plus y squared minus 16 equals 0. That's an on that, but we're good. That one's done. Done, done, done. Okay. B, r equals 4 cosine theta. A lot of times we see that cosine theta, we automatically want to make that x or y. I can't rewrite that as x unless it's got an r in front of it. So in A, we made r squared on the left side by squaring both sides. Here we're going to do it by multiplying both sides by r. And then I get r squared equals 4, and I can rewrite this r cosine theta. My r squared is x squared plus y squared equals 4x. I got x squared minus 4x plus y squared equals 0. Keep in mind here, it's just asking us to convert to rectangular and not identify the conic section as we did in example 11. C, I got r squared equals 4 sine 2 theta. First off, I can't work with the sine 2 theta, so I'm going to use a double angle formula. 4, this becomes 2 sine theta cosine theta. Before I can rewrite those as x's and y's, they need to have r's in front of them, which means that I am going to have to multiply by r squared over here, so I have an r sine theta, r cosine theta, which means I do need to do the same thing to the other side. So let's take a look at what we got here. I got r to the 4th, which, you know what, I'm going to write as r squared squared. I've got 8, and I'm going to separate those r's out, one in front of my sine, one in front of my cosine, just so I know that I'm not missing something. I got x squared plus y squared equals 8xy. I can multiply out that left side. I get x to the 4th, x squared squared, plus 2x squared y squared, plus y to the 4th. And because they asked me to, I'm going to move that 8xy to the other side so I can set this equal to 0. D, theta equals 5 pi over 4. This looks a little different than what we had before. So I'm going to start by jotting down a couple of things I know. Y over x equals tangent of theta. So if my theta is pi over 4, that means y over x equals tangent of 5 pi over 4. I know that's 1. So that means that y over x equals 1. I definitely want the x out of the denominator. This is the line y equals x. If we're going to set this equal to 0, y minus x equals 0. I don't know, maybe it's my age that just bothers me a little bit. I'm going to leave this one as y equals x. R equals 4 secant theta tangent theta. I'm going to start by writing secant as 1 over cosine and tangent as sine over cosine. And so I definitely don't want those cosines in the denominator. I'm going to move them over to the left-hand side by multiplying both sides by cosine squared. I can't do anything with the sine. It needs an r. I also need an extra r over here on the left-hand side. So I have an r for each of my cosines. That gives me r cosine theta squared equals 4r sine theta. R cosine theta is x. I got x squared. 4 times r sine theta is y. Again, x squared minus 4y equals 0. Again, the point of this is just to give you some of the strategies that you will see as you go through these. So f looks almost the same. I've got that 2 cosine squared theta in the denominator, so I'm going to start by multiplying by 2 cosine squared theta. Again, I realize just like in E, I need another r on both sides. What I want to make sure of is that I don't shortchange that right-hand side and only multiply the r by the sine, because that's where I need it. This becomes 2 r squared cosine squared theta is the same as r cosine theta squared. I got an r sine theta plus r. The r cosine theta looks the way I want. The r sine theta looks the way I want. I'm just going to have to deal with that r. So I get 2x squared over here. I get a y. And my r is the square root of x squared plus y squared. Again, we can move everything to the left-hand side. So this is set equal to 0. I'm not going to try to do anything funky and get rid of that radical. It does not make sense at this point. I am just grateful that I'm not being asked to graph this. And that is page 6. We are done.